All right, welcome back. It's time for Chapter 7, Monitoring and Logging. When Noah worked in startups in San Francisco, he used his lunch break to exercise. Good, smart guy. That is a smart thing to do. He would play basketball, run up to Coit Tower, or practice Brazilian Jiu-Jitsu. Most of the startups Noah worked at would have a catered lunch. He discovered a very unusual pattern coming back from lunch. There was never anything unhealthy left to eat. The leftovers were often full salads, fruit, vegetables, or healthy lean meats. Well, of course, they don't taste as good. The hordes of startup workers ate all of the unhealthy options while he was exercising, leaving zero temptation to eat bad food. That sounds great. That's perfect. That's why you go and exercise. And people who aren't making those same kinds of decisions, they get not necessarily what they want, but they get what they've been manipulated into doing, which is eating foods that aren't healthy for them for the reward of how they taste. And then you get a little bit, I would say, harder of a life. I used to go and do something like this. I used to go and I like to juggle, so I would like, I consider that like exercise, and I would do that. And I gotta say, like, it's healthier. It builds your self-confidence to be able to do something cool like that. But it is truly a sacrifice in some ways. Okay, let's continue reading. There is something to be said for not following the crowd. Likewise, the easy path is to ignore operations when developing machine learning models, mobile apps, and web apps. Ignoring operations is so typical. It is like eating the chips, soda, and ice cream at the catered lunch. Being normal isn't necessarily preferred, though. Wait, I'm confused now. I'm lost. In this chapter, the salad and lean meats approach to software development is described. Okay, so likewise, the easy path is to ignore operations when developing machine learning models, mobile apps, and web apps. So that's the equivalent of going to lunch and eating all the junk food, and then socializing with your peers, having strong, enriching relationships, and discussing technical concepts and stuff. I mean, I'm sure that's not what happens. I'm sure it's just gossip and more junk. But as somebody who lived a lifestyle like this, sometimes I do wish I would have like bonded a little bit closer with some of the people I worked with instead of just always disappearing and doing my own thing. But I can on my other channel I'm juggling 7 balls, and I can do all that, and it kept me fit. It kept my self-esteem a bit higher, just to know that I accomplished this thing I put my mind to. And I haven't been doing any of that during the pandemic, and it I definitely advocate for what he's saying here. I think that is the better way to go. But I can see it the other way. First, unhealthy food is, in my opinion, like cigarettes or some sort of addiction. You can't just decide not to eat something that's delicious and there in front of you and ready to eat, and that you can smell. Once you can smell it, once you can visualize it, once you can imagine it, I think it's very hard to just decide not to partake in it. But so that's why it's really important, I think, to kind of remove yourself from that environment. Like, I think environment is really often underestimated as a thing that modifies your behavior. Like, some people think like, oh, I'll just bring a healthy lunch on my own, and then while everyone's having pizza, I'll just eat my healthy lunch. Well, that's not going to work. You're going to find yourself succumbing to that temptation. Anyway, let's keep reading this. I guess I don't understand what he's saying when he says, likewise, the easy path is to ignore operations when developing machine learning. Okay, so ignoring operations is like eating the unhealthy food. Ignoring operations is so typical. It is like eating the chip, soda, and ice cream at the catered lunch. Being normal isn't necessarily preferred, though. In this chapter, the salad and lean meats approach to software development is described. Okay, I need to take care of something. I'll be back shortly. I need to eat a bunch of chips, soda. No, I'm just kidding. I gotta do something else. All right, I'm back. Next section is key concepts in building reliable systems. Having built companies for a while, it's fun to look at what worked on the software engineering portion versus what didn't. One of the best anti-patterns out there is trust me. Any sane DevOps professional will not trust humans. This is good, because this is one of the things that I understand the concept. You shouldn't trust people, but I just don't think that's the right way to say it. Because you should trust people. Like, you have to trust people. There's no other way to have somebody do something for you without trusting them to do it. But trust isn't the whole story. So let's continue reading. They are flawed, make emotional mistakes, and can destroy entire companies on a whim, especially if they are the company's founder. Instead of a hierarchy based on complete nonsense, good luck with that. A better approach to building, they're telling you how to, wow, okay. This book, there's been a few things that have been kind of upsetting to me about this book. The first thing was just the fact that this author seemed to have this wonderful, perfect, professional environment around him where his boss, or his project manager, not even his boss, somehow knew the perfect project for him to tackle that he'd be able to dive into and solve and create all this value for the company. He didn't have to, come into that himself and, rant and rave like a lunatic or a madman about how, this is going to change, only to have nobody believe him and kind of have to just disappear into the darkness and come back and be viewed as a hero for at the last possible moment where he was about to get fired for neglecting his regular duties. Like, that was really upsetting to me that the authors don't really seem to understand kind of unideal environments in a way. This all seems to be framed from the perspective of a professional environment where you can literally do what you want when you want with no consequences or repercussions. Okay. Which, I mean, there are environments like that, and they're wonderful. If you can, if you're dedicated to self-learning and have a lot of things you want to bring to the table. But for some people, that kind of environment can be tough because they just don't know what to do all day. So, they get on YouTube, they get on whatever, and whole days and weeks pass them by and they haven't done anything and they don't really have any good professional experience. So it's kind of a trade-off, because if you're given, focused, regimented, clear objectives, you've basically got things to say for yourself without having to do that. But at the other side of the coin, if you're allowed to, and I think any technical environment will allow for self-direction. I think that's important to any environment, but it's just how much of that you get. If you get a lot of that, the plus sides of that, in my opinion, are you can explore things that haven't really been explored to the fullest. And that can be hugely beneficial. Okay, so instead of a hierarchy based on complete nonsense, a better approach to building reliable systems is to build them piece by piece. In additional, this is the third major typo we've seen so far in this book. When creating the platform, see, it just seems lazy and careless and not really thought through. I guess I don't know what he means by hierarchy. I guess I assumed that he was talking about like the hierarchy of like your like management structure in your company. Like you somehow get to decide who the CEO is. But I mean, obviously he's not talking about that. He's talking about building reliable systems and having some sort of hierarchy for that. But it's not explained anywhere in this book what that sort of hierarchy would be. So I'm lost. Sorry, I'm just completely lost. In additional, when creating the platform, failure should be expected regularly. The only thing that will affect this truism is if a powerful person is involved in building the architecture. In that case, this truism will be exponentially increased. So the truism is, wait, what? Don't they mean decreased? I'm so confused by this. So, what the? Okay, so the only thing that will affect this truism. So this truism, what is that? Let's look at the previous sentence. In additional, when creating the platform, failure should be expected regularly. So I think what they're talking about here is when you build something, you can expect there to be hiccups, road bumps, walls in the building. Let's say I was going to build a house and I wanted, this beautiful door with 3 windows in it to be installed in my house. Door comes from factory, it's only got 2 windows. That sort of thing is going to happen a lot. But I wouldn't necessarily, I guess I would call that a failure if your order was very clear that you wanted 3 and they hand you 2. So I guess failure is an okay word for that. And yeah, you should expect that regularly. Say you wanted pristine, perfect 2x4, and you've got one that's warped, you're going to have to deal with that. Say you wanted a 9x9 something, and they only had a 10x10 something, you're going to have to deal with that. They only have an 8x8 something, you're going to have to deal with that too. So, yeah, that makes sense. So it is a truism that when creating a platform, building anything, failures should be expected regularly throughout, and you're going to need to address those when they arise. The only thing that will affect this truism is if a powerful person is involved in building the architecture. In that case, the truism will be exponentially increased, they are saying, not decreased. You may have heard of the Chaos Monkey from Netflix. I have not. But why bother with that? Instead, let the founders of your company, the CTO or the VP of engineering, do drive-by coding and second guess your architecture and code base. The human chaos monkey will run circles around Netflix. Better yet, let them compile jar files in the middle of production outages and put them on nodes one by one via SSH, all the while yelling, "This will do the trick." In this way, the harmonic mean of chaos and ego is achieved. What is the action item for a sane DevOps professional? Automation is greater than hierarchy. The only solution to the chaos of startups is automation, skepticism, humility, and immutable DevOps principles. Perfect. Okay, I get what they're getting at now. Basically what they're saying is you don't want, and there was a book I read called The Phoenix Project. But actually, no, this doesn't really tie into this. I was gonna say a character from this book is named Brent, and they were saying you don't want Brents, but I really kind of don't think that's what they're saying. In fact, I think they're saying the opposite. You want as much Brents as you can, because Brents are going to build your automation. You just want your Brents to be working on things that kind of serve a wider, greater good, and don't just serve to keep Brent busy. Like you don't want your Brent working troubleshooting all day. You want them to work on automation. You want them to work on like solid documentation, on testing. You don't want them to just be fighting fires and split between a bunch of different things. This here sounds like it's different. Here it's saying, let's say you have a chief technical officer or even a CEO, or let's say you're working for Tesla and Elon Musk drops into your where you're working, your workplace, and he asks to see your code, and he says, "Oh well, it should be this way, that way, and this is wrong and that is wrong." It's like, okay, like I know you're known for being smart and stuff, but we're in here doing this every day, and like I just don't think somebody just kind of coming out of nowhere and saying this is how it's meant to be done has enough of a grounding in reality to really say that. And that's what it sounds like they're getting at here, is that you want to kind of not put your trust and faith in experts, and more have it in principles. Okay, so that being said, there are immutable DevOps principles. It is hard to imagine a better place to start to build a reliable system than this immutable principle. If a CTO is building java.jar files from a laptop to fix production files, you should just quit your job. There is nothing that will save your company. We should know. We've been there. Yeah, I've never experienced that, but I've never worked for a company where a CTO, where I actually saw the CTO. I don't even think I worked for a company that had a CTO, Chief Technical Officer. So they're talking more about like startups where like you'll be in the same room as like the CEO and the CTO. I've never really worked that kind of environment. No matter how smart, powerful, charismatic, creative, rich a person is, if they are manually applying critical changes in a crisis to your software platform, you are already dead. You just don't know it yet. The alternative to this monstrous existence is automation. Humans cannot be involved in deploying software in the long term. This is the number one anti-pattern that exists in the software industry. It is essentially a backdoor for hooligans to wreak havoc on your platform. Instead, deploying software, testing software, and building software needs to be 100% automated. The most significant initial impact you can have in a company is to set up continuous integration and continuous delivery. Everything else pales in comparison. Centralized logging, which I don't know if that is that. I guess that would count as continuous integration. Either that or they're just veering off in another path. Logging follows close behind automation in importance. In large-scale distributed systems, logging isn't optional. Special attention must be paid to logging at both the application level and the environment level. For example, exceptions should always be sent to the centralized logging system. On the other hand, while developing software, it is often a good idea to create debug logging instead of print statements. And this is something I learned how to do recently in Visual Studio. Why do this? Many hours are spent developing heuristics to debug the source code. Bugging the source code just happens without any extra effort. Why not capture that so it can be turned on if a problem surfaces in production again? The trick here is logging levels. By creating debug log levels that only appear in the non-production environment, it allows the logic of debugging to be kept in the source code. Likewise, instead of having overly verbose logs appear in production and add confusion, they can be toggled on and off. An example of logging in large-scale distributed systems is what Ceph uses. Daemons can have up to 20 debug levels. All of these levels are handled in code, allowing the system to fine-tune the amount of logging. Ceph furthers this strategy by being able to restrict the amount of logging per daemon. The system has a few daemons, and the logging can be increased for one or all of them. Case study: production database kills hard drives. Another vital strategy for logging is solving scalability. Once the application is large enough, it might not be feasible to store all logs in a file anymore. Alfredo was once tasked to debug a problem with the primary database of an extensive web application that hosted about 100 newspaper, radio station, and television station sites. These sites generated lots of traffic and produced massive amounts of logs. So much log output was created that the logging for PostgreSQL was set to a minimum, and he couldn't debug the problem because it required raising the log level. If the log level was raised, the application would stop working from the intense I/O input-output. I believe that stands for. Every day at around 5 o'clock in the morning, the database load spiked. It had gotten progressively worse. The database administrators were opposed to raising the log levels to see the most expansive queries. PostgreSQL can include query information in the logs. For a whole day, so we compromised. "15 minutes at around 5 o'clock in the morning." Okay, so that's when they got their log levels raised, for 15 minutes at around 5 o'clock in the morning. As soon as he was able to get those logs, Alfredo immediately got to rate the slowest queries and how often they were run. There was a clear winner: a select star query that was taking so long to complete that the 15-minute window was not enough to capture its runtime. The application didn't do any queries that selected everything from the table. What could it be? After much persuasion, we got access to the database server. And see, this is another thing, like they're just glossing over that. To me, like, that is the main thing. Like, how did you persuade them to let you look at the database server? Like, it's just like, this I find is what is difficult. Not finding out that there was a query all server. Like, if you've got to change the whole paradigm, the whole viewpoint of everyone working there to say, hey, you're doing it this way, and already there, you're gonna tell them they're stupid. Like, you're already in a losing battle. Like, I wish there were books written more about this aspect of it. How do you persuade somebody to let you access a critical system that you're not allowed to access? Like, especially if they don't know the new paradigms and concepts and strategies of DevOps that you're trying to bring to the table, and think it might be a scam or not legit. So I wish they wouldn't just gloss over that. Personally, I've kind of been in a situation like that where I needed to get into systems that I shouldn't have been, but it's I guess the only advice I would have for that is to I would say to try to keep things official as you possibly can. So start by persuading your management, and then if you can submit a ticket, if you can do something in an official way. Personally, that's the way I felt more comfortable doing that, but of course I have seen the other side of the coin where people just learn who is in charge and who they can go and see face to face, go up face to face and say, do this now, please. Like, and sometimes without the please. And that has definitely, I've seen been more effective than the other way, but that I'm not really comfortable doing, because if you mess up, immediately they're going to say, well, this guy came to me, like, but if you mess up and you've got all those official processes and tickets in place, and people know what you're doing, and they know that they could go wrong, and they gave you a time window to work in, that's my advice, is whatever you can do to persuade somebody to give you access to something you're not meant to have access to. The main thing you want to focus on is that idea that you're not meant to have access to it, and try to attack that and change that to say, no, I am meant to have access to this. My job is to work on DevOps and to manage this, and this. Therefore, we need access to this. If the spike in load happens at around 5 o'clock in the morning every single day, is it possible that there is some recurrent script? We looked into crontab, the program that keeps track of what runs at given intervals, which showed a suspicious script, backup.sh. The contents of the script had a few SQL statements that included several select asterisk. The database administrators were using this to back up the primary database. And as the size of the database grew, so did the load until it was no longer tolerable. The solution: stop using the script and back up one of the 4 secondary replica databases. That saved the backup problem, but it didn't help the inability to have access to logs. Thinking ahead on distributing logging output is the right approach. Tools like rsyslog are meant to solve this, and if added from the start, can save you from being unable to solve a production outage. Okay, so let's see if I can get that tool. Did you build it or buy it? It is incredible how much vendor lock-in gets press. Vendor lock-in, though, is in the eye of the beholder. You can pretty much throw a rock in any direction in downtown San Francisco and hit someone preaching the evils of vendor lock-in. When you dig a little deeper, though, you wonder what their alternative is. In economics, there's a principle called comparative advantage. In a nutshell, it means there is an economic benefit to focusing on what you are best at and outsourcing other tasks to other people. With the cloud in particular, there is continuous improvement and end users benefit from that improvement without an aggregated cost, and most of the time with less complexity than before. Let's check their definition here of comparative advantage, which I believe is what they call it. Yeah, comparative advantage. So according to the internet, comparative advantage is the ability of an individual or group to carry out particular economic activities, such as making a specific product, more efficiently than another activity. The law of comparative advantage describes how under free trade an agent will produce more of and consume less of a good for which they have a comparative advantage. Okay, so yeah, it sounds like it's yeah. So comparative advantage in a nutshell means there is an economic benefit to focusing on what you are best at and outsourcing other tasks to other people who are better at that thing than you. Unless your company is operating at the scale of one of the giants in technology, there is almost no way to implement, maintain, and improve a private cloud and be able to save money and improve the business at the same time. For example, in 2017, Amazon released the ability to deploy multi-master databases with automatic failover across multiple availability zones. As someone who has attempted this, I can say that it is borderline impossible and tremendously hard to add the ability of automatic failover in such a scenario. One of the golden questions to consider regarding outsourcing is this a core competency of the business? A company that runs its own mail server, but its core competency is selling car parts, is playing with fire and probably already losing money. That is a good question. Is this a core competency of our business? If it's not, then outsource it. If you're a car company, you should be doing things with cars. You shouldn't be doing things with mail servers. You can hire somebody, you can hire a mail server company to do that for you. And they're probably offering you, they're a business too, so I'm sure they're offering you a fair price for what you get. Better than you could just do it yourself. Fault tolerance. Fault tolerance is a fascinating topic, but it can be very confusing. What is meant by fault tolerance and how can you achieve it? A great place to learn more about fault tolerance is to read as many white papers from AWS as you can. Okay, so this might be a good thing to do for my wild networking series. Open source white papers. But let's continue. This is not Wild Networking. This is this book I have on Amazon Kindle. When designing fault-tolerant systems, it's useful to start by trying to answer the following question. When this service goes down, what can I implement to eliminate or reduce manual interaction? Nobody likes getting notifications that a critical system is down, especially when this means numerous steps to recover, even less when it takes communication with other services to ensure everything is back to normal. Note that the question is not being framed as an improbable event. It explicitly acknowledges that the service will go down and that some work will needed done to get it up and running. Is it just me? I feel like when I'm talking here and reading this, I'm like really staggered, and part of that I think is just because it's still like I'm not entirely like woken up yet, and my health is just completely going off the rails with this pandemic. So like I'm sure I'm. Oh my God. Okay. I gotta stop the video. I will come back to this later. So this is the end. Here, when I come back, we're going to be learning about fault tolerance.